You clicked because you want to see a Raspberry Pi detect human emotions. Well, here it is. Yep, the Pi is actually reading emotions in real time. In this video, I will show you exactly how it works. From detecting faces to passing those faces into a neural network that classifies emotions like happy, sad, or surprised. This was part of a science fair project I built in France, where we explored how machines see emotions compared to humans. Hi and welcome to my channel. Today I'm going to show you something really cool, how a Raspberry Pi can detect human emotions. I will walk you through what it does, how it works, and I will guide you through the code. So, let's get started. So the basic idea is simple. The Raspberry Pi takes an image from the camera, searches for faces in the image, pre-processes it, and then runs each of the faces through a trained model, and then classifies the face into one of 7 emotions, like happy, sad, angry, surprised, neutral, disgusted, or fearful. Here is what we're going to use. We will train the model on the PC and run the model on Raspberry Pi. What you need: Raspberry Pi 4, Raspberry 5 would work better for sure, Pi camera, I am using the camera module V2, adapter cable, cooling solution, we are using the passive cooler, power supply, micro SD card, monitor and micro HDMI to HDMI cable, mouse and keyboard. Humans detect emotions through facial expressions, tone of voice, and context. Here, the machine is focusing only on the face image. The full pipeline is the same as I have explained in my video about person detection, which you can find here. We need to do the pre-processing, create the model, train it, convert the model, deploy and run inference. This time we will not be gathering the dataset on our own, we can use the one available. We still need to convert the model to tflite. However, this time we don't need to convert it to a cbyte array. If we take a look at the pre-processing block, it is also pretty similar to what we had before. Here we convert to grayscale, resize to 48 by 48 pixels, convert to range 0 to 1. There is an important difference though. Before the Pi can guess your emotion, it first needs to know where your face is. For that, we will use something called a Haar Cascade. A Haar Cascade is a classic computer vision algorithm from the early 2000s, before deep learning took over. It scans the image with small rectangular filters, looking for patterns of light and dark. By combining many such simple patterns, it can quickly detect a face. It was trained on thousands of face and non-face images, so it knows what to look for. Nowadays, there are other ways to detect faces: hog detectors, histogram of oriented gradients, or modern deep learning-based detectors like SSD or YOLO. These are more accurate, especially in tricky angles or lighting. So why Haar Cascade here? For Raspberry Pi, Haar Cascade has a big advantage. It's lightweight and fast, especially since we expect multiple faces. Even without a GPU, it can find faces in real time. A deep learning detector would be slower and need more resources. That's why this project sticks with Haar Cascade. Haar Cascade sometimes misses faces in unusual angles or occlusions, but it's good enough for a demo and runs smoothly on a Pi. Did you know that our brains have a part that is specialized in face detection? One of the main components of human facial recognition is the fusiform face area, located in the temporal lobe. This part of the brain plays a vital role in facial recognition, helping analyze features such as the eyes, nose, and mouth. Let's see repo folder structure and let's go through the code quickly. Inside the project, there's a script called emotions.py that trains the model. I used FAIR 2013 dataset for this, you can download it from here. It contains over 28,000 of images, labeled with emotions angry, disgusted, fearful, happy, neutral, sad, surprised. The script expects the images in this location. I started this project from scratch, but I was inspired by several open source examples online, especially a project by Atul Anand on GitHub. The script accepts an argument --mode, which can be train or display. Train will retrain the model and save it. Display will load the saved model and use it grabbing the image from the camera. For the train part, first we prepare our data with image data generator and flow from directory. It will resize the images to 48 by 48 and convert to grayscale. We do it for training and validation datasets. All of the images from our dataset are already 48 by 48 and contain the face in the middle. This is why we don't need to use Haar Cascade for those. Let's create our convolutional neural network. We use similar layers as in the previous video. Next, we train the model and display the loss and accuracy and save the model. If we want to use the model, this is what needs to happen. Find the faces with Haar Cascade, convert to grayscale, resize to 48 by 48 pixels, normalize to the range 0 and 1, run model, get probabilities. The one with the highest probability is chosen. Draw result on the frame and show it. Let's have a quick look at the code as I want to show you the part with Haar Cascade. Notice here that we use the XML, which detects frontal faces well. You don't have to train the model for yourself here, I added it to the repository. Let's see it in action. Next step is to quantize and convert the model to tflite. It's the same as I explained the last time. This time, we don't need to convert the model to C-byte array, as Raspberry Pi will deal with loading files just fine, as there is an operating system. I implemented it in convert.py, and as you can see, it is pretty straightforward. Just a reminder that the representative dataset needs to be converted to what model expects. In the script use-model.py, I basically want to ensure that everything is fine with the quantized tflite model. So I load it, allocate tensors, get details about input, output, quantization values. Next is grabbing the image from the laptop camera, pre-process it, as I explained before, plus convert to int8. Remember, this model has quantized inputs and outputs to int8, and feed it to the model. Then display the image with the results, detected faces in rectangles and emotions. As already mentioned, for this video I am using Raspberry Pi 4 with camera v2. It's very easy to connect this camera. First I need to remove those radiators. Regarding system installation, I did everything in a very standard way, follow the process explained here. Let's ensure that the camera is well recognized. We can run airpycam hello, which starts a camera preview stream and displays it on the screen. Let's prepare the environment. First, let's make sure the system is updated. Install Python and virtual environment tools. Next is installation of OpenCV, which is a library for computer vision, and we use it also in the training script. Next is creating and activating a virtual environment. They are isolated virtual spaces that we can use to run our project without the risk of breaking the rest of PyOS and our packages. In other words, we can do whatever we want here without the risk of damaging the rest of PyOS. We are going to create a vwnv called tflite-env. This is how we enter it. Note that we are not able to use TensorFlow on Pi. We need tflite-runtime. And let's not forget the library for the camera. Let's now copy the necessary files with scp. We will need the model and XML, and Python scripts, of course, if you cloned my repo to your PC. Ensure that they have the permissions so the script will be able to access them. I prepared a script which is very similar to the one that I just showed you, use-model.py, which is called py-detect-emotions.py. What's different? PyCameraLib, and that we can pass the argument to choose the model, which I will explain in a minute. And that's basically it. You can run the demo. If you're still watching, here's the cool part I didn't show before. You can actually teach the Raspberry Pi new emotions. Want it to recognize your own smile? Let me show you how. When you retrain your model on your own, you will notice that its accuracy is only about 60%. I added a feature that lets the PC, can be also Raspberry Pi, but we need to change the library that is used, take the number of pictures you request and store them in folders labeled with the emotion, like happy, sad, or neutral. Each folder becomes part of growing dataset. Once the new images are saved, I freeze most of the existing CNN layers. That means I keep the learned features, like how eyes and mouths look, and retrain only the final layers with your new data. After training, the script automatically sends the personalized model file back to Raspberry Pi, replacing the old personalized one. So now the Pi learns to recognize your unique face and emotions. This is why there is an input argument to run the script on Pi. You can use either default model or personalized with the new dataset. Of course, it's not perfect, but it's a good example of how AI can run on small, affordable devices. And you can extend it. For example, turn on the music depending on your mood, or control the lights. If you want to try it for yourself, the code is available on my GitHub. If you got inspired, enjoyed it, give me a like, subscribe, and let me know in comments what I should build next. Thank you!